Again, my name is Wes Kendall. I'm originally from Tennessee. I've worked at, oh yeah, there's my friend from Tennessee right there. We went to the same college. Sorry, what? Knoxville. Today I'm going to be talking about writing tests for Django applications, specifically using PyTest, which is a tool that I've grown to love over the standard Django test runner. And along with that, I'm going to be talking about like what does it mean to write what I'm calling like a bulletproof Django application with your tests. And I have an example project that I put online, and I think it's actually going to be easiest. There's going to be a lot of code examples and things like that. For people that want to follow along with the slides and maybe have trouble seeing this, just go to this GitHub repository, and or you can type it in directly. And in the README, there's a link to the slides if you just want to follow along with the slides, because I'm going to just be clicking on some links from the slides to open up code examples and things like that. But yeah, before diving into this example app and stuff like that, I kind of wanted to go over a high level like what this talk is about mostly. So what I'm going to be talking about today is like, first of all, writing tests for Django application. And I'm also going to be talking about like the basic Django test runner and what are the differences between using that and then using this tool and framework called PyTest. Have people here use PyTest specifically for Django testing? Yeah, it's a pretty nice framework. So along with that, I'm going to just be talking about like my own personal ways that I go about like testing Django applications. And then I'm going to walk through this application and kind of go over like how I thought about testing it and then go over some examples. So it's going to be fairly high level for the most part. And the intention of this is that you can go to this code base here and you can run it locally. You can even deploy it on Heroku if you want and play around with it and like do a deep dive yourself on all these different PyTest plugins and modules and various ways of testing I'm going to be talking about. So I'm keeping this talk to 35 minutes. Set a timer. I might have to rush through some of the last examples if this goes on too long. Yeah, as just a quick glossary of terms, I'm assuming some Django knowledge, obviously, but when it comes to testing, a test is a piece of code that's written to assert that other code is working. So you're writing code to run your code to verify that it works. The test runner is what gathers all these tests and runs them, reports if there's successes or failures. And the test suite, there can be many types of test suites. These are the full collections of tests, whether they are your integration tests or unit tests. I'll talk about what those mean in a little bit. Continuous integration, often abbreviated as CI, is a tool to run your tests automatically whenever your code changes, such as if you do a commit or if you push. And a fixture is a term that's used in Django often, usually meant to reference when you're loading up a fixture of static data into the database. When we talk about fixtures in terms of testing, it's kind of a similar concept. A fixture is setting up state for a test, and this might be some state in your database, such as a piece of dummy data or mocking out a resource or something like that. And as I mentioned earlier, there's so many different types of tests, and it seems like everyone I've ever talked to has slightly different definitions for all different types. I'm going to be referencing 3 types of tests today. The first is unit tests. These are tests that test a single unit of execution in your code. So it might be a single function. It might be a single branch within a function. It might be a single statement that you're testing. That's typically what I mean when I say unit tests. I think other people might have different definitions. Integration tests are pieces of tests that test multiple interacting components or modules. So it's exercising a lot of code at once down one specific path of it. For example, writing a test that renders your whole marketing side of your application and just verify that it renders. That's an example of like an integration test. A smoke test is something that it's a very quick test suite that you can run like when you're about to deploy, for example. You can run a smoke test, and it's going to exercise critical parts of your application. So it might actually log in and walk through your application, for example, just as a quick check to verify that things seem good. We can go ahead and do QA or whatever other stuff we need to do before we deploy to our main production site. So I'm going to be referencing this. if for any reason something's confusing or you have any questions, feel free to just raise your hand too throughout. Not a big deal at all. So to start, like what is the native Django testing framework and kind of how does that differ from PyTest? So Django's native testing framework, it's actually built off of Python's unit testing module and framework. And what this means is that since Django natively is built off of unit tests, whenever you write a Django test case, you're actually inheriting a test case class, and that inherits the unit test case. And for those that have written Django tests before, which I'm assuming, I'm just curiosity, who has written like test cases for Django? Just even with their, yeah, so you're probably familiar with at least seeing a test case class with test methods, and then you do self.assert equals, self.assert is none, self.assert false, different assertions to verify what's going on in the code. And so these are just some very quick examples of like what a test case would look like. So let's say that you're testing your add function here that adds A and B together. You might have one test method that verifies when you add two positive numbers together that it equals another positive number. And just to check your sanity of your add function, you might even just throw in a test case in there to add two negative numbers together just to be sure it's behaving as you would expect. And then a more advanced test case, again using Django's test case class, you might make a custom user model that is set to active at first, and then you might want to test, like, what if I deactivate this user? I should assert that the active flag is false. A very quick example where when these test methods run, the setup method is called before each one of these tests to set up the data for those test methods. So that's kind of like a quick overview of like how these test classes work at a high level. And like I was saying, Django's test case class, there's actually a lot going on underneath the hood that Django does on top of what the unit test framework does. So for example, every time you run this test case, even though you're just performing basic addition, since you're using Django's default test case module and not like their simple test case or their other test cases, it's setting up a transaction for the database so that if you write any data to the database, it's going to flush it all back so that you have a clean slate for each testing method. It's doing a lot of different stuff. So if you were to write a lot of test cases and they never even access the database, you are effectively just wasting a lot of cycles and resources. You're making your test suite run a lot longer. And it does a lot of other things like that. And then what I mentioned before is, if you write a test case class like this and you have a setup method, you're basically assuming that every single method inside of this class should be using this test data here, because if it doesn't make use of this test data, you're again just wasting a lot of cycles. You're making data that you don't even need for your test, and you can get into a realm where you have like a really sluggish test suite after a while. Things are set up far away, and you don't really know exactly what's going on. So it kind of brings me to what exactly is wrong with the test case. Well, there's nothing really wrong with it. It gets the job done. There's a lot of boilerplate going on. You're importing test case, you're making a class, you're writing methods. You have to remember all these assert methods: assert is none, assert greater than, assert less than, assert dictionary equal, assert set equal. It can be pretty cumbersome to always use the right assertion method. And along with that too, just even using the correct test case depending on what you're testing. So like simple test case doesn't set up the database and do all that overhead. So and like what I mentioned earlier too, especially with the setup method, you always have to kind of keep tests that are really using the exact same data bundled together in the same test classes if you want to use setup really the right way. So this is an example of our Django test converted to PyTest. So again, PyTest is just a library you install, and it provides you a test runner, and it also provides you tools that you can use inside of your tests. And one of the benefits of PyTest is just making your test ideally smaller, more readable, more functional, and being able to share a lot of this data and fixture state that you set up for your test. So the Django examples here, we saw that earlier. The PyTest example, and this is an example of, we have our addition function here. Instead of writing two different test methods, PyTest by default comes built in with a way to parameterize your tests. So you can mark your test as parameterizing them over these parameters. So we've defined A and B and the expected value here. And so we're saying use 2 and 2 here for A and B, and then use 4 for the expected value, and then just run our test function and verify that it, is the expected value. So this is really nice if you're just running different inputs and outputs for a test. You can loop over all of them, and you can run these individually if you'd like. Along with that too, you've noticed that we're using functions here. PyTest, it promotes the idea of using functions over classes. You can still use all the old school test case classes, and it still works with PyTest, but they promote the idea of just using functions, just simple test functions. And the really nice thing about PyTest is that you use just a simple assert statement. So there's no assert equal, assert greater than. You assert whatever you're testing. We're doing a quality check here. If you were comparing dictionaries in this assert statement, for example, PyTest is going to handle everything under the hood. It's going to show you a nice diff of like all the stuff that's different in your dictionaries, if they do differ, and all this nice stuff on top of that. And all you have to do is just write assert. It's really, really nice. The more advanced test case, we have our old Django test case over here that creates a test user and verifies some things, assert false, assert true. Over here in PyTest world, we're doing the exact same thing. We're creating our custom user object, and we're testing the deactivate thing here, where we're deactivating the user. We're asserting that they're not active anymore. Similarly, here we're doing the same thing. And you notice some differences here versus the first example is we're using PyTest mark DjangoDB, and I'll get into what this actually means later, because this marker is provided by a Django PyTest plugin. And what it says is that this test needs to use the database. So please set up a transaction for me. If I write any data here, please roll it back. So you're being explicit and saying, I need to use the database for this test. And if you try to access the database and you don't mark it, it's going to complain. So you'll notice the syntax here of this user parameter being passed into the test. So we saw an example before of parameters from parameterize being passed in. We define these parameters, up here. But if you ever see a parameter being passed into a test and it doesn't come from parameterize, it means that it's a PyTest fixture. And as you can see here, we define this user fixture at the very top. And PyTest fixtures are really nice because it allows you to set up state and then pass along that state to your test function. And at the end of every test, it's going to, well, since this is inside of a transaction, we don't have to clean up this database row that we created, but PyTest fixtures allow you to yield stuff, and then after the yield, you can then tear down state if you need to do that. So PyTest fixtures are really nice. You can set them up for different scopes, so you can have fixtures be set up at the very beginning of a test module and torn down. You can do all these really nice things with them. So again, kind of some of the core idioms and features of PyTest. We're using simple assert statements. PyTest is going to do all the proper diffing for you. And we're writing test functions instead of trying to arbitrarily group things by test classes. And we're using reusable fixtures on top of that. So your test can be very explicit of, I'm using this state, and I need this type of setup in order to do my tests. Along with that, some really other nice features that PyTest has are markers. If you need to categorize your tests, if you need to say this is an integration test, this is a slow running test, you can mark all your tests explicitly so that you can then run them differently for different reasons. Probably the most powerful thing about PyTest that I love is the plugin system. And whenever you install plugins like the PyTest Django plugin I mentioned, it makes available all these fixtures for you to use and all these different hooks and things like that. So what we're going to go over today are a lot of different types of PyTest plugins and how that can make testing more fun and enjoyable, and making your tests run faster and be more clear overall. So you run tests by typing PyTest. So you'll see here, you just type PyTest. You can set up Django so that if you do type Django manage.pytest, it will use PyTest as the test runner, but there's no need to do that. This is kind of what the output looks like just by default. So, I mentioned this before. The reason why PyTest in this example is working well with Django is because I'm using the PyTest Django plugin. By default, PyTest is just set up for pure Python test. But if you use the PyTest Django plugin, It pretty much provides the entire functionality that Django's test case does. So Django's test case gives you a test client, so you can say self.client and do post, get, and all that stuff. Django's test case does database set and teardown, and all these other things. The PyTest Django plugin effectively recreates all that functionality by giving you fixtures to use. So I've kind of just given a very high-level overview, like what is PyTest, what are the differences, especially between just the normal Django test runner using PyTest. So what I wanted to do now was go over a real-world example of a toy project I made, and kind of talk about like how I think about testing and you know, how I go about testing a Django application. So when I said the word bulletproof, I know that's just a random loaded term, but what I meant by that when I'm talking about making a bulletproof application is that whenever you make a bulletproof application, ideally you have really high confidence that if you are refactoring this code base, or a random person that maybe has never seen the code base much before is refactoring it, you have confidence that you're not going to introduce a bunch of random failures. You can refactor things that will run the test suite and kind of know what's breaking. Along with that, you have really high confidence that if you do like a Django upgrade or just a miscellaneous package upgrade, that you're not going to introduce random bugs in the system. Ideally, your test suite is covering a lot of critical parts of the code, and that you just have a lot of confidence that doing very minor things, such as just upgrading libraries, isn't going to break everything. Another thing that I feel is important for a really well-tested application is just having critical end-to-end paths of like primary user experience totally exercised by automated tests. So logging in, going through booking flows, for example, or some of the core features of where you develop. Having all that covered so that, again, if you write changes, you're not going to just accidentally break core features of the site. And outside of just writing tests, what I call like a bulletproof application is one that's structured in such a way so that the complexity is separated and you can easily test different components. And it just makes it overall easier to test. And for those that have been like writing tests for a while, too, I think that a lot of people have noticed, along with myself, is that when you write tests for a while, you eventually start writing code so that it's easier to test too. And you'll hopefully see a couple examples of that today. So yeah, again, there's a completely complete Django project specifically for this talk today. It's at this URL if you want to go to it. There's instructions for setting up locally or even deploying it remotely. And yeah, it's a meme creator app. So what it looks like is, I will probably have to refresh this because it's on the free Heroku tier. But what it looks like has a extremely basic landing page, and I've already registered for an account. It doesn't do anything. It doesn't do anything fancy with email validation or anything like that. In practice, it should validate emails for people to register. But basically, with Meme Creator, you click Create Meme, and it calls the Image Flip API. Image Flip is just this random service that has an API for grabbing the top memes. Grabs the top 15 memes here. So you can choose a meme. You just click on it, and then you can write the upper and lower text. Fails. Yes. You just click Create Meme. This is going to hit the API again to create a meme, and you'll notice like here it saves it in our database, so you can go back and view it later. And yeah, it's just a fun little app. And you can log out and do all that stuff that you might normally do. But anyways, yeah, that's the app, and it's structured into 3 primary Django apps. So if we go to our apps folder here, you'll see there's a marketing page, and literally all that is that really basic home page that you're redirected to if you're not logged in. There's the user app, which just has basic user login registration. It pretty much just inherits a lot of Django's built-in user authentication views. The core app is this meme app, which has one model, and it saves the meme for the user, and the URL to the image that was created from the Image Flip API. And it also just stores the creation time so we can order it on the main page. You also notice in the meme app we have a wrapper for the image flip API so that we're not hard coding requests everywhere. It parses some of the results, just makes it easier overall. And yeah, that's really kind of like the core structure of this application. So given this relatively simple application, just backing up and determining how should we go about testing this, the way that I personally go about testing things such as this is that first I usually determine some high-value integration tests that can be written. And what I mean by high value is like writing the lowest amount of code that's going to cover the most code. So writing like the shortest, simplest tests that are going to exercise the most functionality of your application and give you the most bang for your buck. And typically after I do that, I will think about areas of the code that are really, that do a lot of branching and that are more complex. So you could think about, like, for example, if you have a booking page on your app and it calculates the order of a cost or the cost of an order, and it does all this different logic, you probably want to write a lot of different unit tests for that test all the different edge cases. So typically I'll think about different areas of the app that do a lot of branching logic, and those are the areas that I'll try to cover in a lot of unit tests and iterate over all the possibilities. For example, like our API wrapper, it parses the API results, it handles errors. Like that's a case of something I would unit test here starting out. Then after that, I typically think about areas of the application that are completely out of my control and might even change. And one good example of this is the image flip API itself. It's not versioned at all. So if for whatever reason they just change it one day, they change the schema of it, it would be nice if we had some tests to at least let us know, hey, this API is completely different. You really need to update your app. And finally, after that, like after getting kind of the base things out of the way, I will test the more nuanced stuff. So going to the meme page for the first time and making sure that if you have no memes, it gives you a useful help message that says create a meme here, just basic stuff like that. So yeah, I mean, I figured I would just spend kind of the rest of this time going over the tests that are written on this app, and I'm going to try to go over the basic ones first, and they get a little bit more complicated quickly. But yeah, the first one is, again, it's high-value integration tests. And this example is just basic page running. Like, let's just make sure that the marketing site renders. And the example for that test is here. And this is what it looks like with PyTest. We have test marketing site. And you'll notice here that it takes in client. And as I mentioned earlier, if you ever see a PyTest test and it takes in an argument and you don't really see that argument defined anywhere, it means that's a fixture. And this fixture may be defined by your internal project somewhere in a thing called a conf test file, which allows you to share fixtures among all tests, or it might be defined by a third-party plugin. In this case, I know client is defined by the PyTest Django plugin, and it gives you what the Django test case would give you when you reference self.client. So we're taking the client fixture here because we need to do requests to our website to see that the marketing page renders. We get the URL of the marketing page, and then we call client.get on that URL, and we verify that it returns a successful 200 response. And just as an additional check, we verify that our tagline is in the content of the marketing site. So with 4 lines there, we have really high value integration tests. We're exercising so many components of the code base just by doing this. We're exercising the URL patterns that we defined, the templates being rendered, the entire request and response cycle is being exercised just by this. So it's a really short, really nice high value integration test. Another high value integration test is access control. So this app is using something called Django Stronghold just to be sure that by default, every one of your views are protected. So you actually have to explicitly mark views as public if they shouldn't be protected for only authenticated users. So just to verify these assumptions, we can write some integration tests to make sure that our views are public. For example, these are the user registration and the user login views. We want to make sure that these are publicly accessible. We don't want these to be behind an authentication wall. So we take the client here as a fixture, and the view name is the parameterized thing coming in from PyTest parameterize. We're reversing that view name, we're getting it, and we're asserting again that we can access this page. It returns a 200 success code. For the private version, we we assert, this is in a different file and it's linked in the slides, we assert that the status code is the 302 and that the response URL is the login page. So we know we're being redirected to the login page. That's kind of how we know that, the views that should be private, like the meme creation views, are protected. So another quick high-value integration test, homepage redirection. So if you go to the root URL, just the meme creator root URL, it should direct you to the marketing page. If you are not logged in, it should redirect you to your meme page if you are logged in. So this test goes through that. Oh wait, I don't have that one loaded up. Oh wait, no, here it is. Yeah, so this test does that. So testing redirecting to memes when you're logged in. So we have a client again. I'm going to go over what this authenticated user in because it's a special thing in this app. But again, we grab the home page for this example. Since we're logged in, we should be redirected to the memes page. So again, since this parameter is not defined here anywhere, it's a fixture. And we've actually defined this fixture inside of our app. It's a special fixture defined by our meme creator. And I mentioned something about conf test files earlier. You can make a conf test file in any folder. We have it in the root of our project now. And depending on where it's at, everything that's under that hierarchy has access to these fixtures defined in this file. So, oh, this is an old version, but it has authenticated user. So we defined the authenticated user here in this conf test file. And that means it's accessible by all of our tests that are under this folder. We need to take the Django client fixture because what we're going to do is we're going to create a user. This G thing that you're seeing here, it's a package called Django Dynamic Fixture. It makes randomized data for you, except for the fields that you fill out. So it makes it really easy just to create quick models where you don't really care about the other fields except for the fields you care about. So we make a user, we set the password, we save, and then we log in with the test client. So now we have an authenticated user. And again, the nice thing about this is that we can now use this fixture for any of our tests where we need to have an authenticated user first that needs to do requests to the site that are protected behind an authentication wall. This test is the most complicated, and I'm going to spend the most time talking about this one. And this is kind of our last high-value integration test. And this tests the full meme creation flow. So what this is doing is it's actually loading up the choose meme page as an authenticated user. It's clicking on the first meme that it finds. And when I say click, I mean it parses the HTML, finds the URL, then it loads that URL. So it takes you to the create meme page when it goes to that URL, and then it posts to that page. So it posts the, the 2 text fields that's needed, and then it verifies that the meme is created. So there's some additional setup for this one because we want to make sure that when we test our meme creation flow, as you remember, it's hitting the image flip API underneath the hood. It's actually calling out to a separate API. We really don't want to do that in our automated test. We don't want to have it so that when we run this every time, it has to hit this other API, especially if that API is creating resources underneath the hood, which image flip is making memes. You really don't want to waste other resources, and you want to make sure your test suite is predictable so that every single time you run it, it should ideally have the same result for continuous integration type stuff. So the way that we get around this is that we take the wrapper that I made here for the image flip API, and we use a thing called a mock. Out of curiosity, how many people have used mocks and patches for tests? Yeah, so there's some familiarity here with that. But what a mock is essentially is it's, again, another library. Previously in Python 2, you had to install a library. At Python 3, it's part of the unit test module, so you can import mock from unit tests. Mock allows you to patch out paths of code, whether these paths are functions or if you're patching out a method on an object. And what that allows you to do is to override the behavior of these functions or methods or even variables. So you can patch it out, and I can say, every single time that get memes is called here, I'm going to return this array of results, because in reality, if I was calling get memes and I was hitting the API, I would expect it to return a list that looks kind of like this. Autospec, out of curiosity, how many people use specs when they write mocks or have used autospec before? It's something I actually don't really see too much in practice. So when you mock out something like this, underneath the hood, everything that calls it it can actually call it with whatever parameters it wants. And it's going to track every time you called it. It's going to track every parameter that you've called it with. So that's kind of dangerous, though, because if this function signature changes one day and your mock is still calling it with the previous parameters, it'll just let it pass. AutoSpec actually inspects the arguments of get memes here. And every single time this mock is called, it ensures that the function is called with the proper signature, otherwise it fails. So it's a nice additional safety method on top of your mocks. There's a little bit of overhead associated with it. So anyways, we patch out these two endpoints, the one that gets the memes and the one that creates the meme. We make it return some dummy data. We grab the choose meme URL, and then we use a library called Beautiful Soup, which I'm also assuming some people are familiar with that. We take it and we actually parse the result of the choose meme page, and we do a CSS selector to find the very first meme link there. And then we load that URL for the choose meme page, and then we post to it. So we post our upper text and our lower text, and then we assert that that takes us back to the meme page, where we can see all of our glorious memes we've created. And here at the very end, we assert too that we made an object in the database, a meme object, and it has the proper parameters. Additionally, you could assert that your mocks were called with the proper parameters. I typically do that too, but I left it out of this test. Again, this test is going through essentially your entire flow. It does have some stuff mocked out, like your API, but it's covering a lot of different code paths, and it's another example of a high-value integration test. So like I mentioned, and let me just make sure, yeah, I'm pretty good on time. So like I mentioned, we were patching out the API wrapper there fully that time. And so if you ever changed, if for whatever reason your API wrapper was wrong, you wouldn't catch it with that test. So this is the part where we start writing unit tests for more complicated stuff like the API wrapper. And if we look at just one of the examples of our API wrapper, we can see whenever we call get memes here, this is the function we patched out in the previous test. It calls responses.get on the actual API endpoint. If the status code looks good, it loads up the JSON, and if the JSON has a success parameter, which ImageFlip gives you the success key, then we actually return the content we care about. Otherwise, we raise an ImageFlip error, or it's just a custom error that we made. So like I said, there's actually a lot of different branches for this. First of all, the API endpoint, it might return a 500, so that would throw an error, or it could return a 200, and ImageFlip could just say an error happened. So those are different cases where an error would be raised. And we want to make sure that at least our API wrapper here is doing the right thing upon different responses. So I have an example of this that's linked. This is just one example of testing that get memes function, and it's testing with a successful response. And it's using another PyTest plugin called Responses, which is actually a library developed by Sentry. And what Responses allows you to do is it allows you to add a fake response for an endpoint, and allows you to even say what status should it return and things like that. So here we've added this fake response. We hit our wrapper, and then we verify that it parses this response properly. So again, we go over different failure scenarios. We verify that an exception is raised whenever a bad status is returned, like a 200 or a bad data entry. And this is an example of just unit testing our API wrapper. And again, we're still patching out stuff, and that's just to make sure that our unit test suite runs the exact same way each time. But oftentimes you'll get to the point where you just really want to verify that the thing that actually calls the API is doing the right thing. And this comes down to this thing I was talking about earlier called smoke test, where we just want to do some quick verifications and assumptions about, and verifying some assumptions that we make. And so I have an example of some smoke tests here where, like, what if the ImageFlip API suddenly just changes? And so in this test case, we actually hit the real endpoint itself, and we validate the response against this schema as this other Python library for validating a dictionary structure against a schema. So you'll notice here that we mark this one as a special type of test. And what that means is that we can, I think, I have to remember the syntax, but what this means is that we can now just run our smoke test. I think that'll do it. So I have a connection error because I haven't successfully provisioned my ImageFlip username and password. So you need a real username and password to run these tests. But by default, we have set this up though so that their test suite does not run smoke test by default. So I'm running kind of out of time here, and there's some, oh, that was pretty much the last example. So big question is like, where do I go now that I have this test suite? I have all these things tested, like what should I do with it now? How should I integrate it into my development workflow? And a tool that I love that I'm sure many of you are familiar with is Coverage. So what Coverage allows you to do, and there's a plugin called PyTest Cov, and it gives you this --cov option. It will tell you every single line of code that your test suite covers. So if your test does not exercise like an if branch or an else branch, it's going to tell you here in this coverage report. As you can see here, we've written sufficient amount of tests such that every single branch of our code is covered. But it's a nice way to at least kind of see what areas of your application are missed by your test suite. Some people like to even enforce a minimum amount of coverage. That seems to be like a touchy topic for a lot of people. I think a lot of it depends on how long your test suite is and how it's all structured. Yeah, another thing too, once you have a great test suite, setting up continuous integration. So in this repository, I have an example of using Circle CI for doing integration. And what it means is that every time we do a push, Circle CI is going to run our test suite for us and give us a pass or a fail. And you can even set up Circle and things like that to do nightly tests. So you can set it up to run your smoke tests every single night or do special things like that. Another thing too, now that you have a test suite, you can think about optimizing it. So PyTest has a great plugin called PyTest XDist, and I have all this linked. But if you install this plugin, it gives you this -n option. So the nice thing about plugins is they can actually add options to the command line. So PyTest XDist adds this -n option, so I can run my test suite in parallel. So I just ran it with four processes right there. It actually ran slower because I have so few tests that the overhead of spinning up processes makes it run slower. But if you have a really large test, you can get some pretty big wins out of just parallelizing your test suite. And PyTest, this plugin just does it for you out of the box. It's really great. I mentioned earlier about test data. I use Django Dynamic Fixture in this example. There's another great testing data framework called Factory Boy. It allows you to make much more realistic testing data. So like, let's say you have an address field or a zip code, you can fake out all that data and make it a little bit more realistic instead of just using randomly generated data, which is what Django Dynamic Fixture generates. So yeah, like I said, go play with the app. Feel free to download it, run tests locally, or deploy it. And yeah, again, this was meant to be just a high-level overview of the many different tools and techniques, specifically for Django testing with PyTest. So yeah, feel free to reach out, and I'm happy to take questions here. My contact information is up there. And I think we'll post a link on the meetup or something. So yeah, appreciate it.
We've got time for a few questions for Wes.
Yeah.
So I'm sort of grappling with where PyTest backend testing, which can still be integration testing and deep testing, overlaps or leaves off when a front end group wants to do Selenium testing. And they say, well, let's use PyTest as the Selenium runner. Great way you can utilize all of our fixtures. It's sort of like the overlap is really blurry.
Yeah. Yeah. So the question was like the overlap between, let's say you have a Django test suite, but then you have this maybe completely separate front end where you want to run Selenium tests or like actual headless browser tests or whatever you call it. I'm not much of a front end person, but you know, I guess your question is more about like, is there a way to integrate the two so that you don't have, so that you can at least utilize the same fixtures of your Django thing? I haven't used I haven't set up any type of test yet where you have a completely separate front end that's deployed that would hit an API endpoint. So I can't really comment too much on how you would set that up in practice. I do know that with the Django test case and even with PyTest, you can set up a live server, and maybe that would be helpful in setting up a test suite where you could communicate, JavaScript communicates with a live server. I'm not really too familiar with how a lot of people do Selenium-based stuff. From what I've heard, I think a lot of people just mock out API responses, correct? But that only gets you so far, obviously. But
so part of the question is that Selenium seems to be kind of expecting the URL to hit, but when test runners running, the URL is all internal.
Yeah, so I haven't played around with this much, but I do know there is a live test client option where you can have a live test server running, but I haven't played with that much. You could even just look it up right now really quick, but I have no idea if this would actually work for Selenium, but I do know that there's this, this is so small, there's this fixture that's provided. I know it's here really quickly. Oh yeah, live server. Yeah, runs a live server. So maybe something like this would work where there's actually a live server you could hit, and you could at least utilize the same type of database setup, set up fixtures and stuff like that, and then run your JavaScript to hit a live server. That might work out. I haven't really done it in practice though, so that might be a way. Yeah, you're welcome. Yeah. Oh, thanks. Yeah, so the question is like, do I strictly abide by like test-driven development, for example? Is that your question? Okay, yeah. So okay, so test-driven development, for those not really familiar, it's and correct me if I'm wrong on this, but it's the development pattern of writing your tests first and then writing your code. So you're writing up all your assertions. You're saying, hey, if I hit the marketing side, it should return this, and then you write your code. When it comes to doing a project from scratch, I'm not really much of a follower of test-driven development because I refactor things so much in the beginning to get to a structure that feels nice. When things get more kind of ingrained and they're not changing much, that's typically when I like to be more rigorous about testing. I've never really followed test-driven development much in practice, though. I don't know if that's hindered me in any way, but I typically still write tests after I've like really clearly defined the data structures, their interactions, and modules. Because oftentimes when I write applications, it's just I get it working to a certain point, and then I realize that my initial assumptions are all wrong, and I should structure it a completely different way. So oftentimes I've kind of felt that doing test-driven development sometimes hinders that process, or makes it more just kind of drags me behind. So does that make sense? Yeah. I don't know if anyone else has any comments around that, or if they do test-driven development, but I actually haven't really used it successfully in practice. So, yeah, did you have a question? Or yeah.
We have seed data spread across multiple tables. How do we test that?
Yeah. So your question is like, what if you have seed data spread across multiple tables? So you're basically asking like, what if you wanted to set up a bunch of database state right at the beginning of your test suite? Your application's assuming that it's there, and then you want to run your entire test suite, and you want to set it up once at the very beginning of the test suite and then tear it down at the very end. Is that kind of my understanding? Yeah. So with the PyTest database fixture, so by default, when you mark your test case as needing the database, it's going to set up a transaction, and before it even does that, all your migrations are going to be executed. Your database is an initial state, and then every test runs off of that initial state. So you can modify that initial state with a fixture here. It's called DB, and they have some examples of doing this, but you can make a fixture that uses the database fixture, and then you can set it up to do some, whatever provisioning you need to do, and then you can return that fixture such that every single thing that uses the database has those has that state, and then every transaction is on top of that state. Yeah, I hope that there's a pretty straightforward way of doing it with PyTest. You set up a fixture to do it effectively. Something I will note really quickly, Django has the notion, it has a setup test data method on their test class, and that allows you to set up test data for each class, which is pretty nice, and then tear it down. PyTest doesn't really have the equivalent of that, and that's like something that's kind of missing. So I think there was another one, or yeah. Yeah, so the question is like, how do you get 100% code coverage when you're intentionally? Yeah. Yeah. So the question is like, I showed an example earlier. My code base had 100% testing coverage. How does it have 100% if there are things that I'm specifically not covering? So those examples that I was mentioning where I mocked out the API. Yeah, I don't run the API there, but I have unit tests that run over the API. So I just have a bunch of different tests that cover different parts. So some tests mock out larger resources, and then other tests will actually unit test those resources that are mocked out. Does that kind of make sense? Yeah. Something nice that I like about coverage too is you can cover your tests. So if you named your test wrong, you didn't name it test underscore, it doesn't get executed. So then you know, oh, I named it the wrong thing. It's never executed. You see it in your coverage report. Any other ones? Cool, thanks.